All right. Well, welcome everyone. Thanks for joining us in the first session of the Data Science Development Series. I would like to give you a very quick background about this series. So we know data science is an emerging field, and we know that many people are interested in getting into data science. However, most of the time people got overwhelmed with all the things that are out there about data science, and they get kind of scared about how can I get started my journey to data science. So we designed this series as a community initiative in partnership with Pandera Systems and TAB. And the way we design it is it's 6 parts as of now, and each part is about 90 minutes. 60 minutes will be actually a lecture about one of the core skills in data science. And the instructors have been selected carefully from the industry. So they are people who are actually doing data science for a living. This is their day-to-day job, and they know what did work, what didn't work in real world. So the instructor is gonna give 60 minutes of instructions about that specific core skill. Today we are talking about machine learning 101, which, as you know, is very important in any data scientist to know about. So machine learning is definitely one of the most important core skills in data science. And that's why we chose to start with it. Then you're gonna have the other ones, the computer vision, the deep learning, the search and relevancy, the NLP, the recommendations. And then 30 minutes after the 60 minutes lecture, there will be open, there will be open for questions and answers. So please feel free to prepare your questions, ask your questions, and we will have plenty of time, 30 minutes at the end, to answer all the questions that you guys have. That's all I wanted to say. Welcome again, and thanks for joining us. Brian?
Great. Thanks, Khalifa. Well, hey everyone, I'm Brian O'Connor. I'm going to be the host for this 6-part series, so gotta get used to me because I'll be here every Wednesday at 5:30. But I'm the director of data science at Pandera Systems. I get the fortunate ability to work with different clients across industry, across different problems that need to be solved. So I have a broad understanding of, a lot of the key data science topics that we'll be touching on every single week, right? Some of the stuff that you're going to be able to learn is, we have this week machine learning. Next week we're going to be talking a little bit about deep learning. We have natural language processing. We have computer vision. We have recommendation, right? So as part of this 6 weeks, you're going to get a broad understanding across a lot of different domain expertise within machine learning and data science. So with that, once again, I'll thank the sponsors who are going to be Pandera Systems, as well as TAB, which is Tech and Beer. We'll have events coming back later with TAB where it'll be more in person, as soon as we can. And then Southern Data Science Conference as well. Please, follow us on social. I think you're going to like our content that we have here. And we'll be able to provide more, through our social media channels for all 3 sponsors. So I'm going to hand it off to Jingjing Canyon, who is the data scientist at Home Depot and going to be the instructor for today on Machine Learning 101.
Sure. Thank you, Brian. And thank you, Khalifa, for the introduction. I'm going to share my screen. Can everybody hear me? Yeah? Okay. Can you guys
Yep.
see my screen?
Yes.
The slides or the GitHub? Sure.
Yeah,
the slide.
Yeah.
The slide? Okay,
the slide.
Good. Okay, good. Yeah, so today, thank you for your time joining us. My name is Jingjing Cannon. Really thank you for your time. Today, I know there's some live show about SpaceX and NASA going on about 30 minutes ago, and really appreciate you invest this time with us and also invest this time in yourself. And yeah, this is our 6-part series. Khalifa and Brian already went through this, and this is our Southern Data Science Conference page. yeah, I just want to mention one thing, that the goal of this 6 data science series is that we want to give back to our community, and our inspiring leader, Khalifa, is also the founder of this data science conference. And I really appreciate that mindset, and it's really my great honor to be part of this. Just a little bit about myself. So I did my PhD study in computational neuroscience at Georgia State University. And I started my first job as a credit risk analyst in finance industry, doing credit risk modeling. And then I joined Verizon as a junior data scientist, working on risk management and data analytics. And then I joined the Home Depot as a data scientist, worked with the online data science team. And actually, right now, currently, I'm in a transition to a new company called DataScan, which is a division under Toyota Southeast Finance. And I'm going to lead the data science initiative in the company, and also build out the data science department. Here's my LinkedIn. Feel free to add me, and I will be happy to connect with you. If you have more questions, I will be happy to help if I can. Okay, so first is the agenda. I think, yeah, so because it's a online session, we don't really have the face-to-face interaction, and I don't really know my audience. But from my previous experience with Meetup and the conference, and I have been with Southern Data Science Conference for 2 years. I have been volunteering to teach the workshop for 2 years. So based on my experience, I know that normally the audience are either already in the data science field, or they're working in a different field. A lot of them are software engineers or developers want to explore more data science field. And also a large part of the group is students from graduate schools or with bachelor degrees. So today basically it's called Machine Learning 121. So for those who you are already in the data science field, you might find this as a very general and light in review of the basic concepts. For those who are kind of new to this field and trying to explore more, you will find this session as a very general and good starting point to help you explore. And today my goal is to cover data science and machine learning as wide as possible, but not go into too much depth. And if you want to learn more details and more information about some specific topics, I have some links in my slides, and also you can see all these major topics, and you can Google them and learn more. And also I made a GitHub for this presentation, and I will introduce each topics with Python code throughout my presentation, so you can get a feel how it really works in Python and how it looks, like for example, some visualization. So the first part, I will give a general introduction about data science and machine learning. And then very important thing is how you process data, how you prepare your data for modeling, and then machine learning model development, and then how you validate your model. And then I will show some basic data visualization in Python. And then second part is supervised machine learning, and third part is unsupervised machine learning. So in these two parts, I will introduce the basic and classical algorithms for each of them. And I will explain what's the difference between supervised and unsupervised machine learning, and how you use different algorithms to achieve your goals. And also, throughout this whole session, I will use a case study from a RecSys Conference challenge. And especially for supervised machine learning, I will use this case study to compare all these different algorithms, how they worked, and how the results are different, and how we choose based on the results. And also throughout the session, if you have any questions, feel free to chat, to put it in chat. Brian will help me coordinate with the question and answering part. And so the session, throughout the session, I will talk about 1 hour, and then we have 30 minutes Q&A session in the end. So if you have some question, maybe not really related to the topics on the slide, you can save them in the end. Okay. Okay, so first part, some machine learning basics. So who is data scientist? So I would say in the past decade, we probably hear a lot of people talking about data science, data scientists, and it is one of the hottest job in the market and is really high in demand. Yes, that's true. Actually, myself as a data scientist, I feel the same way. The job is really in demand, and a lot of companies are hiring for data scientists. Not only those technology companies in West Coast, but I see Atlanta market space, almost a lot of the companies, medium-sized, small-size, big-size company, are transforming their business to a more data-driven or data-inspired, like how they make business decisions based on data science. So it is a very hot field right now. So who is data scientist? Here's a picture, very interesting. Like, first of all, you need to, if you want to be a data scientist, you need to know the basic math and statistic behind it, right? So you need to understand the machine learning, statistical modeling, experiment design, for example. And today we will go through machine learning, for example. And then second domain is that programming and database. Yeah, I would think data science still requires a lot of computer science background. You need to know how to program in scripting language such as Python. And today I will show in my GitHub how to use Python for each steps. And then also very important skill set for data science is how to use the database. For example, SQL, or nowadays more and more companies are moving to cloud computing space, as I see. And then third one is the domain knowledge and soft skills. So yeah, if you are working in a business setting, right? So domain knowledge basically is that you need to understand your business. You have that business sense and know how to use data science to change or improve your business. And then the last one is communication and visualization. It's also a soft skill, how you communicate with your coworkers, how you present your work to the leaders. And so visualization here comes in place as a very important part, basically how you present data in a very interactive way, very easy and clear pictures, right? We will go through this in a little bit today as well. So yeah, I think probably part of the group here today, if you are new to the data science field, here are some basics, like what skill sets you will need to get an entry-level job. And then also what kind of mindset we have as data scientists. It's a very high-level general introduction, bullet points. Skill sets, first, as I mentioned in last slides, query language. So you need to understand how you get your data, how you extract data. So like 5 years ago, I started working and I learned SQL query, Microsoft SQL, and Teradata, and also then later on learned Hadoop data lake. And then in the recent years, I see more and more companies are moving to cloud space, such as you probably heard AWS, right, is from Amazon, and Google Cloud Platform, and also at Azure from Microsoft. So those are the major carriers. So nowadays, more and more companies are using query language within the cloud space. And then second skill set is data analysis and modeling language. I would say the most popular one nowadays is probably Python. And we here in Home Depot, basically almost all the data scientists using Python. Some people use R, still using SAS, some of them in the finance industry. So Python and R are open source language, so which means they're free. So if you are new to the data science, I think it's a great start point for you to explore Python or R. Basically, they're free, so you don't need to pay for license, and then they are huge community on the website. If you have questions, you can just Google them, and you can find all kinds of forums help you through your coding experience. And then for data visualization, you can use Python or R, or a lot of companies also use Tableau. It's a very good software to allow you to do more advanced visualization. Okay, next part is the data science mindset. Basically, what data scientists do day to day, what we think when we have a business problem or data science problem, how we approach it and how we solve this problem with the data science mindset. So first step, of course, we will need data, right? So we need to collect data. Collect data, there, like you can query data from structured database, or you can do online scraping if you don't have the data you need, and can be creative. And then data preprocessing, I will go through that in details later slides, and data modeling as well. So data modeling here is basically the machine learning part. What's the base statistical algorithms you need to know, and then the last result visualization. So I don't want to spend too much time here. This is just a bullet points you can keep in mind. And also we will share the slides in the end. So you don't need to worry about taking notes and multitasking that, and we'll be open with everything we go through today. So what is machine learning? Machine learning, three parts, three major concepts: supervised machine learning, unsupervised machine learning, and reinforcement learning. And today in my session, I will only go through supervised learning and unsupervised learning. So what is the difference between supervised machine learning and unsupervised machine learning? I got this question a lot of times. So simply speaking, supervised machine learning is that when you have label for your data, which means that you know what you are predicting. So your data has a predictive target. And within the supervised machine learning, there are two classical problems. One is regression, normally used for forecasting, and the other is classification. So basically you can categorize your data. So it's easier for you to use in the future. For example, customer retention. When I was in Verizon, I worked with churn model. So churn model is characterized two categories. One is whether the customer will churn, means that the customer will leave a Verizon subscription, go to other carriers such as AT&T. And the other is that the customer will stay. So there are two predictive targets. So that's for supervised machine learning. And unsupervised machine learning is that when you have data and the data doesn't have label, so you don't have that predictive target. So a lot of times unsupervised machine learning is to discover the pattern within your data and then find those billings within the pattern. For example, one is the clustering, like you can cluster your data into different groups, and then you can use that as a classification, right? And then the other is dimension reduction. So if you have high dimension data, for example, you have data with thousands of columns, or you have image data, those are very high dimension data. So if you want to see if there's some pattern within the data, you will need to do dimension reduction. So I will go through each of this today in detail, in more detailed slides, and also with some Python code. I think probably most of you already know how to install Python, but this slide basically is for the people who is at the starting point and trying to explore Python or data science, right? So this is my favorite toolkit. I use Jupyter Notebook. So here's the how you install Jupyter Notebook. Jupyter Notebook is one product within Anaconda. So it's a very simple and interactive coding environment. So you can try from there. Okay, so after we go through all the tools and skills we're going to cover, and we're going to start our basics today. So first, I want to start with the data. So before we do modeling, we need to understand our data and also prepare our data. So by understanding our data, I mean, you have to understand the data types. So for structured data means basically you have columns and rows, right? Those are structured data in Excel sheets or in SQL Server or in your cloud server, right? So is structured data here. And later on in our later sessions, we will also talk about unstructured data, such as language and image. They're not really, you can not really put them into Excel sheets and into column and rows, right? So, and for our session today, we'll only focus on the structured data. So structured data type, two major types, categorical data and numerical data. So categorical data, there are many types, and just want to point out two examples. Nominal data, so basically is the data used to label the variables and then provide a kind of a quantitative value, but it cannot be ordered or measured. For example, zip code, right? It's not really the numeric meaning there, but it's kind of a category, right? And then ordinal data is another type of categorical data. So it's ordered the category, but it has no quantitative difference between the values. So for example, size, you have actual small, medium, large, for example, etc. So it has intervals, but it cannot really measure the interval. And then the second big category is numeric data, basically numbers, right? So numbers, numerical data, we have two major types, interval and ratio. Interval is basically the ordinal data, but you can measure the intervals. For example, Home Depot, we sell products, sale price. You have a units to dollars, for example. That's a measurable interval, right? And then ratio, basically, simply speaking, percentage, right? So why I point out different data types here is because when we pre-process the data, different data type requires different methodology. Okay, that's the next, how we pre-processing our data pre-processing. So there are listed a few examples, and what we need to do normally first is the data quality assessment. Is very important first step. When you, for example, if your manager hand you a data set, right? First of all, you need to make sure that the data is right. It's the correct data. So there are a few checks you can do. One is missing data. If you have data missing, and then second is that you have do you have duplicated data, and then third is that if you have outliers that you need to remove. I will go through details in Python later. And then second one, feature aggregation. So this is more like a data transformation, like if so you can basically aggregate your data and making data into a way that you can put it into a better perspective. Like for example, you have sales data, and then if you put into a month by month, and then you can see the trends over the year, right? Simply speaking, like that. And then third one is the feature sampling. So a lot of times, sometimes we need sample of data, like get a subset of the data through a large, huge amount of data, to do a lot of statistical analysis. And then also, when we do modeling, a very important step is to split your data into training data set and validation data set. And here requires data sampling method. And then fourth one is dimension reduction. So dimension reduction is one method to do feature selection. I will go through that in the next slide. And then next one's feature encoding. So feature encoding here, feature encoding normally is used for categorical data. So if you have categorical data, they're not really numbers. And you know, the computer cannot take anything other than numbers to compute in their model, right? So first step is that you have to transform your categorical data into numbers. So there it will be a one-to-one mapping from a category, for example, category A, B, C, D will have a one-to-one mapping into 1, 2, 3, 4. Right, so and then that's number, you can put numbers into your model. And I will go through that in my Python code in a little bit too. Okay, next slide is talking about examples of the feature selection and feature engineering. Feature selection, as I mentioned in last slides, it is required when you have a lot of predictive variables, which is also called features. So you have a model and you have so many inputs, and then a lot of times they are mostly noise, right? So that's why we need a feature selection. And here are many ways to do feature selection, and I will showcase a few of them in a little bit in my Python code. See how you do this feature selection and remove the noise. And then the second one is feature engineering. So this is required when you don't have a lot of feature. So for example, you only have one or two, a couple features, and then you want to predict something and you will realize that this is not enough information, right? And then here, feature engineering comes into place that help you to create more features based on the limited existing features. And I will use an example from the RecSys challenge in 2015. And you can go to this website to see more details on what they're doing. And RecSys is a very, very famous and well-known conference worldwide for recommendation systems. And every year they have this conference in different places internationally. And then every year they also have some challenge competition for people, for data scientists to compete. And I use this one as an example for today to go through feature preparation and also data preprocessing, and then later on the model building part. Okay. First is the feature engineering example. So this is what we get from the data set, from this RecSys challenge. They post a data set. So the data set basically has click sessions. So this is an online recommendation system. When you go to a website, for example, homedepot.com, right? And you look for some products to do home improvement projects. And then you probably click on some power tools, click on some decor, or click on some stuff. And then in the end, you bought some products. And then all the click action were recorded on our website. And then later we use that as our data to train. This is not Home Depot data, it's from the RecSys system, RecSys challenge. But it's very similar concept. So we have the click data. So for example, session ID. So each time you come on the website, and then the timestamp, what time you went to the website, right? And then what you clicked, item ID, and then what you bought in the end. There's multiple items. And then what the category the item belongs to, and what the price the item is, and how many did you buy in the end, or you didn't buy anything, is 0, okay? So this is all the data inputs they have, and then they want the people in the competition to predict what the customer, whether or not the customer will buy in the end based on their clicking activity. So you can immediately find how, okay, this is not really a lot of information. You only have like 5 columns, right? And it's probably very hard to have a very accurate model to predict whether the customer will buy in the end. So here, it is why we need feature engineering. It's basically to create more features from the existing feature. For example, this is what I did. This is just a few examples what I did. So for example, from the timestamp, you can find out a categorical data is which day of the week will have most sales. For example, you can see Sunday, we have Sunday and Monday, we always have the peak. And then that's probably correlated to whether you will buy depending on which day you come to the website. And then time of the day, again, from the timestamp, we can find, okay, it's early morning, afternoon, or night. And you can find that morning area, like between 8 and 12, we have most people buying, okay? Interesting, right? And then from the item ID, you can find whether that item is popular, right? So basically, if this item is always bought, but a lot of time this item has been bought, we can call it a popular item, or it's not a popular item. So this here we can create a category, whether popular or not popular, based on our selling history from the item ID, right? And then we can also have a frequent clicked category. You can find which items are always being clicked. And then that might have some correlation to whether customer will buy that one. Maybe because the website design, that white item is always on the top and most people will see that item, click and buy. So that might have some correlation with the buying activity. Okay. So I will show the steps I've shared just now here. Here's my GitHub, and I shared the address on my slide, and we will send out later again. So don't worry, you need to write down anything. So here I have all the code for today's session, all the model algorithms, pre-processing, and feature engineering. So feature engineering, I did it in SQL. I'm not going through line by line what to do, but basically just introduce this concept to you. You could be creative. You have limited features, but you can create more. Okay. Here's the basic SQL query. And then you can look at them later if you want to learn some SQL querying. And then here's the pre-processing part I mentioned earlier, and I want to share like those, what is VIF, what is correlation, how we run those, right? Can everybody see it? Okay. Oops. Okay, here. So pre-processing. So here is the data we got from the website RecSys, and after the feature engineering, I created about 20 features out of 5. Okay, and here are all my features. You can see them in this data set, and each row is a different session ID, and we want to predict whether within this session we will have a buy or not buy activity happen. And this is our predictive target. It's already provided in the data because they already in the data set, they already told us whether or not they bought in the end of the session. Okay. So this is a very classical supervised machine learning. We have labels, predictive target, 0 or 1 is our predictive target. And then you can see here is a like a encoding, right? So days, Monday through Sunday, we don't want them in text format, so I give them different numbers, 1 to 7. And also you can check out something called one hot encoding. So that will transform your categorical data into numeric format. And so you don't need to hard code this way. It's automatically transform them into numbers. And then after you load a data set, here train, you can look at the information and you can quickly assess that if you have missing data. So for example, the session ID should not be missing. So that's the total number of your total rows of your data, right? And then you can quickly see some of them have missing data, right? They're not, they're known there. So here comes how we deal with missing data. So normally, two ways. One way is that if that data is required for your model, you can simply just delete that record. Or if the data is not that sensitive, and you can fill that data. So fill that data, we call it missing data imputation. So a lot of times we use mean or median to fill your missing data, and here's the code. Okay, and then after this one, you should see all the data are filled, and then you won't see this missing records there. And then I have some more encoding to put categorical data into numeric data. And then the other script lines, one line of script is that you can describe your data. Basically, this is some very basic statistical analysis of each of your column. And you can find count, mean of your column, standard deviation, mean, percentile, and max. And then you can easily find out if there's some outliers, or if some data distribution with their standard deviation, okay? Okay, so that's all we have for pre-processing. And then we talk about feature selection with correlation. If you remember that slide, how we select our feature and only select those features with high correlation with our predict target. So we can downsize our features. Here, actually, it's not really big problem because we only have 20 features. We can use them all, but here I just want to show you how you use code to calculate Pearson correlation here. So basically, you calculate each column, which are your features, each feature, how they correlate with your predict target, right? And positive, so here are the coefficients. So positive means they are positively correlates. That means if this variable increase, your predict target will increase. Or if it decrease, the predicted target will decrease. And then negative, that means is a negative correlation. And then here, the higher the number, so it's always between -1 and 1. So for example, if it's between 0 and 1, the bigger the number, the better. That means there are more correlation. If it's a negative number between 0 and -1, so that means if it's more negative, smaller the number, the more correlation. Basically, that is the slope of your curve, okay? And then, so here shows how you do correlation. And then here shows the VIF. I mentioned the other way to do feature selection. VIF here calls variance inflammation factor. So it shows you if there is multi-collinearity between your variables, which means that whether two variables, they are correlating with each other. And if they are correlating with each other, a lot of times it's very bad for regression type of modeling, because basically they interfere with your model so strong, right? And then make your model not accurate or not stable. Okay, so here are the lines how to do VIF. And then one takeaway tip is that normally if you find that your VIF is more than 5, you probably don't want use that variable for your regression type of modeling. Okay, so that's all for the data pre-processing. And let's go to the next slide if we don't have any questions outstanding by far. Okay. Okay, model validation. So I will skip the model development for now because I will go to details on how to use different algorithms to develop your model. But the last part of your modeling part development is that you need to validate your model. So validate, how you do model validation, classical way is to look at the confusion matrix. So confusion matrix, basically you have your predict result and your actual results. So actual results, basically the predictive target we have in the data set. I just showed 0 and 1s, right? And then predictive class is the results from your model. So if the actual says this is 1 and I predict it's a 1, that means it's a true positive. But if the actual says is 0, but I predict that one as a 1, that's a false positive. If the actual is 1 and I model, my model predicts 0, that's a false negative. And if the model says is, I'm sorry, if the data actual says is 0 and my model also predicts 0, that's a true negative. So here shows the classical ways to measure your model. One is called precision. Here's how you calculate your precision. And also the other one is recall. And then we also use a F1 score, which is more weighted way to look at precision and recall together. And then I will show this later in my slides, how I use this metrics to measure the data. So you just need to remember 3 basic metrics: precision, recall, and F1 score. That's how you decide if your model is performing well, okay? And then the other way to visually look at your model performance is ROC curve, and then area under the curve. Here shows a ROC curve. So basically it's plot the true positive against the false positive, and you can see a curve. And then you can see the diagonal line here is basically 50% chance. It's like random guess, right? You flip a coin, you get 1 or 0, right? The face or the tail, right? It's 1 and it's 50% chance. And when you have a model, you can predict better than random guess, right? And then this is how your model perform. If you're new to data science, just a takeaway tip is that the more curvy, so basically the more this curve towards this angle, this area, the better your model is performing. And then also you can use Python to calculate area under the curve. The bigger area under this curve, the bigger, the better your model is performing. Okay, so those are the concepts for modeling and data pre-processing. And before we go to the algorithms, I want to quickly show data visualization, because you can already do them with your data during your pre-processing and look at the patterns within your data. Let me show on my GitHub. Okay, it's all on the list. You can look at them later. So here shows visualization, and T-SNE is the second one. It's for high dimensional data, how you reduce the dimension and plot them. So first, let's look at basic visualization. Here I'm using 2 data sets, ARIS, classical machine learning data set. You can download them on the websites, on their websites. ARIS the flower data set and then the wine review data set. And I want to introduce Seaborn as the plotting library. I personally like it. And then first, I want to introduce the scatter plot. Here you can plot the length against the width, the petal length against the width. And you can see how the data, these two columns distribute on the 2-dimension space. And then you can also introduce a hum function that will allow you to plot different class into different color. And you can see there are 3 types of flowers, arrays. And if you put different color for each different category, and then you plot the same width and the length, you will see them kind of have 3 kind of different clusters, right? And then the other one is the lie plots, and you can use this to, for example, do trending type of analysis. And then this one is the histogram. Histogram allows you to see the frequency in your data, and you bin your data into different bins, and then you can see how often they appear within your whole data set. And here shows the bar plot. Basically, you can also see the trend and the count, right? And here, this one is the wine. Second data set is a wine review data, and they have a wine review score. Like the customer review the wine, they have kind of the points, like whether they like or not. And then you can see when you, here what I want to show here is a box plot. Box plot allows you to see the deviations within each, like the points, right? Was deviation around 95.95 and was around 100, right? And the last one, going back again to the arrays data, we can plot a heat map data, so you can see how the data distributes in a mapping picture, and you can see like how these 4 columns, how they plot against each other, and then you can tell the counts based on the color, darker or lighter. Okay, so this is the basic plotting, and you can try them later, try with this code and just explore by yourself. And then the next one is the high dimensional data using t-SNE. So high dimensional data I already talked about is that it has a lot of columns, for example, thousands and millions columns, or image data, or language data, right? They're very high dimension. They're not just 2-dimension, right? So first we need to use t-SNE to reduce the dimension into 2. So if it's more than 2-dimension, we use t-SNE to reduce it into 2-dimension. So then we can plot the data into a 2-dimension space. It's easier to view. And for example, here is an example, and I upload the data. This is the original dimension is about 2000 times 60. That's a high dimension data. It's not 2 column rows, right? And then after we do t-SNE here, we can reduce them into 2-dimension, and then we can plot the data. So basically, yeah, I cannot print that data because it's like image data is the numbers from 0 to 9. And then each number is an image, a black and white image. And then after we use t-SNE, we can plot that data into a 2-dimensional space. And then you can find that the clusters based on that, based on the visual here, like each cluster represents a number here. And if we introduce the color here from 0 to 9, each of them, you can easily tell that which one correspond to a number, right? So this cannot be done without dimension reduction. Okay. Okay, we have talked about a lot of data, and I will probably go a little bit over time for 1 hour, but we'll still keep it 90 minutes, okay? So next is the supervised machine learning. I've talked about that when we have a label, right? We have predict target, how we can use a statistic modeling to predict that target. So as I mentioned, first very classical way is use regression. And then you probably heard about linear regression. I'm not going through linear regression in this session today. I will just briefly mention logistic regression. So logistic regression basically is to discover the relationship between the dependent variable. Here, the dependent variable is a binary, which is the predicted target I showed just now. For example, 0 and 1, whether buy or not buy, right? And then how that one is correlates with independent variables. Independent variables here are the predictive variables, are the features I talked about, like how many I click, which one I click, what time I click. Those are the features. So it's basically discover the relationship between the independent variable and dependent variable. Okay, let me show on my GitHub what I did for logistic regression. Is here. So same data I showed you before, okay? And then we have predictive target. I removed that because I'm doing some pre-processing. And then actually it's very, very easy in the code how you do logistic regression, just a few lines of code, but you need to understand the logic behind it so you know how to tweak your model if it doesn't perform very well. Okay, so here basically is the whole logistic regression. And here you can see I split the training data and validation data already before I put them in. So here what I put in is already only the training data set. So normally people use 70% of your data for training and then 30% of the data for validation. So why we need to separate them is because we want to keep that validation data set not seen, unseen by the model. So we can validate the model, how the model perform on the unseen data. Okay, so when we train the model, we only use the training data set. And here you can see that logistic regression score is not really good, but we normally look at the ROC AUC. As I mentioned just now, is the area under curve, that score. So I said the higher, the better. And here is about 61%. Not really good, right? Because random guess is 50% correct, 0 or 1, right? But we'll use a model, improve a little bit to 61%. But I just want to show you how the logistic regression work with this data. And then here is how you plot a ROC curve, as I mentioned earlier, how it looks. Okay, and this is the training data set. You can get the score. And then the next step is that you want to validate your model. That's more important than how your training data is performing, right? Because you want to know how your validation data set, that unseen data, basically after you develop a model in the real world, if we have new data come in, how that model will perform. So that's why we look at the validation data set performing score. And then you can see ROC curve is about 62. So here, what you need to do two things. One is that you need to decide, okay, if that 62 is good enough for your model or for your business case, right? If you need to do more to improve it. And the second thing, you need to compare your training data set score, here 61%, to your validation data set score, 62%. What you need to compare is that you need to decide whether these two numbers are close enough to make sure your model is not underfitting or overfitting. A lot of times we see a lot of overfitting. Overfitting, how you define overfitting is that the score from your training data set is much larger than the score from your validation data set. So basically that means your model is adapting to the training data set so well, and then it cannot performing as well for the validation data set. So that's the two concepts you might want to remember how you validate your model. So this is logistic regression, and then second one, this tree-based model. So tree-based model, two major one is decision trees and random forest. So you can see here, decision tree very straightforward, is works really well with categorical data. So you have categorical data, you have, so for example, this is one variable, tier production rate, reduced or normal. If it's reduced, we put it into this category. If it's normal, we put it into the other category. And then later on, within this second layer, we use another feature, and then we use just basically have a tree structured decision making and how we should go classify our data, right? And then personally, I don't use decision tree a lot because a lot of times I see overfitting because decision tree, just based on this structure, it's very easy that model kind of memorize what's happening in the tree in the data and then overfits your model. I will show in the Python code in a little bit. And then a little bit better than decision tree, I personally like that one, is the random forest. Random forest is basically multiple decision trees and then take an average or kind of weighted calculation among all the trees. So you have a more stable or more reasonable results, okay? Let me show the code very quick. And I basically just want to show why I say decision tree is always overfitting. And that's not the first time I saw that here, and it happened in this data set again. Let me see, decision tree and random forest. Okay, so same data, and then same training and validation split. And then we put training data into the tree. Again, very easy line, just a couple lines. You can do a decision tree modeling. And then when we see the training data set, the model performance is 96%, 97, almost 97%. That's very, very high accuracy. That means 100 times, 97 times the model is correct. Okay, kind of that, kind of how to interpret. And this is a ROC curve. And then why you see kind of this square shape is because it's a classifier. It's between 0 and 1. And then if we use a decision tree regressor, it's even higher. The number you see is 99%. The number alone itself already kind of alarming because too good to be true. Okay, so that's why we want to look at the validation data set. And let's look at the score. Ooh, 65. That means when we put the training data set in there, and the model improve based on the training data set, it can achieve very high accuracy. However, if we give a validation data set, which is unseen data, the data cannot perform really well. And as I said, that's a typical overfitting problem. And if the model is overfitting, we normally do not want to use that model. Okay. And random forest. Here, random forest, why I like it better, because it avoids overfitting, because of the average kind of weighted way to calculate a lot of trees that will avoid the overfitting, because you see training data set 76% and then validation data set 76, pretty consistent. That means the model doesn't have overfitting problem. Okay, that's tree-based. And next one, you might think this one is not very common. We might not heard it before. It's called CAD Boost. I really like this one. This is a, compared to decision tree and logistic regression, probably a little bit newer technology. It was developed in 2017, and it was by Yandex. If you haven't heard of Yandex, Yandex is a Russian company. It's like Google in Russia. Yandex is their search engine in Russia. Very, very technology company, has a lot of great open source stuff, and CAD Boost is one of them. So CAD Boost, I don't want to go to too much details and how it works for the interest of time. So basically, CAD Boost is a gradient-based decision tree boosting algorithm, and it put your data into a water and then compute one by one, and each time they compute based on the last iteration. And that's two benefits. One is that it makes really accurate, makes the model more accurate than classical regression or tree. And second, it's much faster. It runs really faster than a lot of other boosting algorithms, because a lot of the traditional boosting algorithm, they do data point one by one. Excuse me. So there are more details if you want to look at them, and if you have more questions, we can discuss later on the Slack channel, or you can shoot me email on LinkedIn. I'm not going to show the Python code. I have Python code on GitHub, and you can look at it later. So this is artificial neural network. The last algorithm I will talk about. My favorite algorithm, because my background is in computational neural network. It's basically what I kind of studied in school. So artificial neural network is based on intuition from biology, right? From neuroscience, how our brain works, but not actually. If we have biologists and neuroscientists in the audience, you probably don't agree with me. And I don't agree with that too. It's called artificial neural network. It's not really how our brain works, but it's inspired by how our brain works. So basically, you see each of this circle here is a neuron. And then in our brain, we have layers and layers of neurons. So this is a mathematical model mimic how our brain works in layers and layers. So all this here have different weights here. So you go through layers and layers of computation, and then last you have the output layer and decide whether what the result would be. So this is also called deep learning. Basically, it's kind of still kind of black box research. Recently, I saw a lot of research on how to interpret or visualize neural network. Is very interesting research area as well. So it's hard to explain this in just a couple minutes, but I want to show you how you use it in Python, so you can have a quick start, just get a feel how you can code it, right? Okay, so yeah, I should be able to finish in 10 minutes, so we can do our Q&A. I only have a little bit left. So here is neural network. Same training data is the same. So here where we start model. So here I'm using a Keras model, a sequential Keras model. There are a little bit more lines, right? But I'm not going through line by line, but I just want to give you a few takeaway points. Like when you see that, oh, my neural network is not working, or how can I tweak it? So you can try a few things, a different activation function here. You can change, or you can change a different optimizer, or you can change try different loss function. And then just try around that and see if you can get a quick fix to improve your model performance. And here, like this epoch is like how many iterations the neural network going through. So here you can set it. You can set a 10 iteration or 100 iteration. Normally, the more you get a higher accuracy. And this neural network is not working very well for this case study. But later on, I figured out a way to tweak it and make it really performing well. It's not tweaking those activation functions, but I went back to tweak my data. So because I have a lot of categorical data, right? So that might be one reason why it's not working so well with neural network. So I tweaked the data using transformation methodology. One is normalization. The other way is standardization. You can Google how to do them. So basically is working on your data distribution and make them more normalized and standardized, and then input into neural network. I improved the performance from about 50% to 80-something%, just simply tweaking the data distribution. Okay, so yep, let's go back. So why I go through all these algorithms, actually I want to show what here. This is like very important last step. Okay, we tried all these different kind of algorithms. We didn't know which one would work. That's why we try, right? Try different algorithms. And then we compare them together, and then we can easily find out which one is the best performer. And here is the matrix CatBoost, the CatBoost one regressor, and can achieve about 75%. Why we're not using decision tree again is because it's overfitting. You can easily tell from this picture. Okay, if we don't have any outstanding question, I will, let me see, I see one. Yeah, I have a question from Jaya. So he was asking the neural network sequential. I showed in my code, it's a Keras sequential model. Okay, and so he asked, does this execute in an order from input to hidden layer 1, 2, and then the output? Yes, exactly. Yeah, you're right. Yes. Okay, so I'll be very quick about the unsupervised machine learning. So unsupervised machine learning, I don't really have a case study to tie that to the RecSys. So I want to go through two major methodology for clustering. So as I mentioned that unsupervised machine learning, we don't have predict target. We don't have labels, right? It's more for discovering the pattern within your data. And here, a very classical or normally used methodology is called clustering. So what clustering mean? Clustering means that you group your data points into different groups, right? Based on their distributions, for example, right? And the data points, they're more similar to each other. Okay, I saw your question, Pam. Now I will answer it later, okay? After I finish this clustering. Clustering is basically put a similar data points and form the cluster, okay? Simply speaking. Okay, and then one classical algorithm is called k-means clustering. So k-means clustering basically is use each data points and find the patterns and then find the centroid. So what is centroid? Basically, it's like you see when you see a plot like this, two-dimensional plot from your data, right? You can see these clusters, but how does the k-means find out there are 3 clusters in a mathematical way? So basically, for example, the k-means, you define 3 clusters here, right? And then k-means will find the centroid. Basically, it's the center of each cluster, and then measure each point within that group, the distance between that point and the center, and then kind of average or aggregate them together, and then until it finds a optimal number of centroid or optimal number of the distance aggregation. Let me show a quick example so it's easier for you to understand what it means. Okay, k-means here. So basically, this is a data set we got from online, and you can see this copy of this website. You can go to this website to learn more details. So basically, first is just a scatter plot. So we have 2 columns in the data, and you can see just scatter plot, right? See there are 4 groups you can see. But why we use k-means is that a lot of times we don't know if they are clusters or how many clusters we should define within your data. Okay, this is just a simple example that show you that you can simply say there are 4. So, but a lot of times I said you don't know how many, right? How many clusters are there, and sometimes scatter plot doesn't really show you that, right? So here's why we use k-means, that you can define the number of clusters, not define, you can compute different numbers of clusters and then measure the distance between each dot and the center, and then see how you get more cluster will improve the accuracy, kind of the distance, right? So here is like number of clusters. So the more cluster you have, you will have smaller distance, right? So WCSS is basically that aggregated score, measuring all the distance between the dot and center. So the smaller, the better. That means your cluster are more clear, defined from other clusters. That means your data are more separated accurately into different groups. But when you plot, when you increase the number of clusters, you can find that that score doesn't really increase that much. So a lot of time, the optimal one is where you can see that the score, the decrease slope, not that sharp anymore. So here you can decide for this data, probably 4 cluster is the best. And then you can plot the centroid. So how you use this, basically I had a use case, I don't have time to show it today, is that I have like search terms, like people search different terms, and I can use natural language processing to process it, and then use k-means to cluster the search terms. And then I could see like clear clusters, and then look at each cluster, the frequent terms. You can define the topics. So topics of that cluster, and then use that methodology. You can basically categorize your data into different categories. Okay, last slide. Yep, we'll be finished very soon. Last slide is the other clustering methodology. It's called hierarchical clustering. So it's different from k-means. It's totally different algorithm. So in this technology, it starts from each data point and then go find similar data points and group them into clusters. Okay, and you can see there's a hierarchy structure here, and then you can see all this green get grouped together into this cluster. Simply way to explain this clustering methodology. I think that's all I have for today. Thank you very much for your time. And I have 2 questions open. Three questions open here. One is first one is from I'm sorry if I mispronounce your name. Really sorry for that. Aparna, and she asked, she asked, is there any easy method to test the number of trees and tree depth? Very good question. So based on my experience, I remember there's some recommended number to start with. How many number of tree and how many layers and leaves you want to go to. I don't have the exact number in my mind right now, but there's a recommended one on the documentation, on scikit-learn documentation, how you start with. So how you find the optimal? Basically, you just run several iterations and find how you tweak that 2 parameters, how that could improve your model. And then you can find at a certain way, certain direction, you improve, and then at a certain point, you don't improve that much. That probably around there is your optimal parameter. And so this is very common practice for parameter tuning. It really based on how much time you have to tune your model, to perfect your model, or you have more time to research, or you have more short timeline, so you can basically have a bigger interval to change your parameter until you find a acceptable model performance. Okay. I hope that answers your question. Second one from Daniel. He asked, any resource for machine learning using R? Honestly, I'm not R user, but I want to share with you how I learned machine learning. It's really just Google. Yeah, Google, and then when you use Google more and more, you will find forums and some websites and some blogger, and you feel that they are very logical, very good and reasonable. And the other really good website for my coding issue is Overflow. Yeah, Overflow basically is a very good platform. And the other, a little bit more advanced, the GitHub. You can find a lot of code there. I believe R has a lot of resource online too. I can add some resource in the end on the Slack channel or in my slides before I send out. I hope that can help. Okay, next one is from Jill Ferry. Would you use an unsupervised learning model to create a categorical feature for another supervised model? Great question. Yes, I did that before. Yes. As an example, I said I showed before for that k-means clustering, like I have like millions of search. People come to website and search different products, right? And then I really don't know what they're talking about. So I use k-means to cluster them into different categories. And each category has a topic. And then that's basically the label of that data I use later for my supervised machine learning model. And that's a great question. And yes, I did that before. Next one is Praveen asked, how do you fix overfitting problem? Overfitting problem, yeah, you can use k-fold cross validation function. So that basically chunk your data. So for example, here I split up my training data and validation data 70 and 30, right? That's static. They're always the same. But the other way, you can use k-fold cross validation methodology that chunk your data to different groups, and each time training use a different set of your data. Okay, so basically your model will adapt to the whole picture. Okay. Next one, Mariam. Okay, what is the height in the hierarchical diagram? That's the distance between your clusters. Okay. Next one, Praveen. How do you decide which model to use for? Sorry, it disappeared. How do you decide which model to use for your business case? Very good question. Based on my experience, so if I'm dealing with structured data, which means it's not NLP or computer vision, I would try different methodology. I personally like boosting and neural network, but it's neural network, is more complicated and takes more time to develop and research and tooling. And also for production parts, you put a model, deploy your model is harder. So always keep in mind for business, in the business case, it's a trade-off. You want a simpler model, easy to put into production, but maybe you have to give up some accuracy there, right? Or your business case just requires really accurate. You probably want to go through different classical methodology and find the best, and work with the IT, see what's the opportunity to deploy your model. Okay, Jamie Zhang, does the task of data scientist get tedious sometimes since you're always dealing with data? How do you like this career path? Yes and no. You sometimes get tedious, like if, for example, like for some business use case, like especially during the exploratory data analysis stage, you explore your data, you want to do the proof of concept, and you want to figure out, oh, does it really work for this set of data, or the other category of data, or this category of data, and then you just repeat your work over and over again. But what opportunity from tedious irritation is that you always can figure out a way to automate your work by yourself. If you find that you're doing some work over and over again, that's probably time you can write some code in Python to automate that process. So next time you just click one button or just run one script and everything produce your results. And then the other, I say no, it's not tedious because I'm working in the business setting. So each time is a different business problem. It's very real world problem. It's very interesting to me to see that we can apply data science to really improve the business. By improving the business, there are always two ways to think. One is that you help the business generate more revenue, or you help the business cost saving, right? So basically, that's how you see your contribution. And then also, it's a fancy title. We are data scientists, so that like algorithms and all this techniques are very new still to a lot of industry. So I really enjoy the career path. And I also have, I think this career has a lot of potential and improve, and you will grow a lot in the future. Did someone just, okay. Good. I have 2 more. I have 5 minutes. I think we're good. So next one's Vivek. To what level your executives at Home Depot have to understand machine learning model to identify the business use case? Yeah, this is a very, very big part of data scientist work. How you present your data work, or the other way, how you sell your work and get buy-ins from leaders. It's a very interesting process, and based on my experience, I have worked in different industries and different companies, small companies, big companies like Verizon and Home Depot. It's a constant task for data scientists, where sometimes also the sell our own model, our own data. So basically, it's communication skills and presentation skills. So keep in mind, as what I see, the executive leaders, they are not normally in the data science field, right? They have a lot of knowledge in business, and they have a lot of skills in leadership, but they might not know a lot of details about data science modeling. If you go tell them, hey, I tweaked this activation function and my neural network, boom, worked perfectly, they probably will ask, so what, right? That's a lot of times I get, so what? So basically, when you present to leadership, what key to catch their attention is how much revenue I can create, or how much cost I can save. Basically, what's your impact of your model? What's your impact of your work? Okay. Next one, will we get this recording sent to us? Yes. Oh, we have more. Okay.
Just take a few, Jingjing, just take a few more while we have the time. I need to figure out how to shut off the Q&A, but I'm excited for all the engagement. Okay,
I will just take one. Oh, I see some people are helping me answering. Thank you. Yeah, thank you so much. And I will take one more. That's our last. What's the most industry currently using machine learning? I would say, as what I see, all the industries are using machine learning, and industries are trying to transforming to machine learning. And actually, I see finance might be a very started earlier than other industry, because like credit risk is already a very classical machine learning problem. And I also internet website, HomeDepot.com. I work in this space, online. E-commerce use a lot of machine learning, and also you see those tech companies, Google, Facebook, LinkedIn, search engines, and that's why we will do computer vision NLP search recommendation in our later series. So please keep tuned, and we will send out more information, and you can learn more. Okay, I think, great. Yeah, thank you.
Great, thank you, Jingjing. Yeah, we have a lot of questions in here. We did try to answer throughout the time. If you do want to go over to the answer tab, there's a lot of your questions that may have got answered by either myself or Josh Ferreira or some other attendees on the call here. But other than that, we just can't go all night. They keep coming in. I really do appreciate the engagement. But yeah, so that's it. We do have a Slack channel that everyone should have received an email for. Please join the Slack channel, and some of these questions that may or may not have got answered today, post those right back in the Slack channel. We're going to have a group, kind of watching over that Slack channel and being able to respond to you on that channel. Now, that's all for today. We'll see you next week when we go over computer vision. I appreciate it. Thank you, Jingjing. That was a great job.
Thank you. Thank you all.
Great. Thank you, everyone.
Thank you, everybody.